Given an arithmetic series, the first term is 16, the 21st is 24. Now, an arithmetic sequence is when you are just going up by the same amount every time. So maybe I'm going up by 3, and I have this sequence. The series is then when you start adding the terms together. So in our case, we've got 16, and the 21st term is 24. Right, the quick way to do this is to spot that we're going to be adding on 20 differences. And that is just going up by 8. Because every time I go up by a term, I'm adding on a difference. So the second term, I would just be adding 1 difference. The 21st, I'm adding on 20 differences. And therefore, D is 8 over 20, which is 4 over 10, or 0.4. You might prefer to do this question by using the nth term. And the general, I should say, general arithmetic series will be a plus d plus a plus 2d, and so on. But in fact, the nth term, so the second term, I just add 1 lot of the difference. The third term, 2 lots of the difference. For the nth term, it's n minus 1 lots of the difference. So then we could substitute that in. We could say that, well, a is 16, and then 24 is going to be a plus, sorry, I know what a is, don't I? 16 plus n minus 1, that's 20, lots of d. And from that, we're going to get the same answer as if we just sort of do it intuitively. I'm just saying you could also do that approach. Anyway, let me just highlight my answer. And then we're asked to find the sum of the first 500 terms. So we've got A, remember, is 16, D is 0.4. The general sum of an arithmetic series is a half n brackets 2a plus n minus 1d. This is in the formula book. So for us, S500 is going to be a half of 500 times 2 times a, so 32, plus 499 times 0.4. Half of 500 is 250. We get 57,900. You have to learn to prove this formula as well. Do you know what? I think I'm going to talk about it, show you where it comes from, just as a little bonus. Like, do practice it, it comes up every now and then. So the sum, like I said before, is going to be a plus d, and so on, up to the last two terms, a plus n minus 2d and a plus n minus 1d. But what we can do is reverse this sequence. And the reason we do that is that now we can just pair them up. We can say, right, here we actually have 2a plus n minus 1d. But as I go up the sequence, the term on the top, I'm adding a d, and the one on the bottom, I'm actually minusing a d compared to the ones on the left. So the pair always stays the same. Okay, all of these actually add to the same thing. And I have n pairs. Because I've got n terms, I've got n pairs, so I just need to times that by n. But what I've actually done is add 2 lots of the sequence. So then I can just divide through by 2, which gives me my half n times 2a plus n minus 1d. It should also just be said that, remember, a plus n minus 1d is the nth term, which we sometimes just write as L, the last term, and you can also write it as a half n a plus L. So L is then a plus n minus 1d. Okay, just a little, I mean, this is not required in this question, just a little reminder to learn how to do that, practice it, and also, it's good, interesting to see where it comes from, because then we can just apply it quickly, like in this question here.